Welcome to the GMAT Strategy Podcast. You're here because you believe there's a better way to study for the GMAT, and so do we. We created the GMAT strategy to maximize your results and minimize your effort so you can get to the fun parts about business school and life as quickly as possible. My name is Isaac Puglia, and I've been teaching GMAT classes and tutoring privately for the GMAT for over a decade, and I've achieved a 99th percentile GMAT score and helped thousands of students get into the business schools of their choice. I'm excited to be a part of your MBA journey since we all at TGS believe that our world can benefit from the best possible business leaders that we can find. If this show is bringing you value, please share it with your friends and family who are studying so that together we can make this process as easy and as painless as it can possibly be. Let's go. Welcome to Real GMAT Problems, episode 42. Doing real GMAT problems is one of the most proven ways to make test day go well, so let's talk through a few examples. The problems that we're going to go through are from the 11th edition of the Official Guide for GMAT Review, and you can web search them if you'd like to follow along visually. Just so you know, the 11th edition of the Official Guide is out of print, and that's partly why I'm going through questions from that book, because that way, if you purchase this year's official guide, there shouldn't be any overlap with the questions that we're going to work through here. The official guide contains retired problems that have appeared on past GMAT exams, so these are going to be extremely similar to what you're going to see on your official GMAT. I'll give you a chance to work through the solution on your own if you'd like, and then I'll discuss my thoughts on what to learn from each question. I recommend pausing after I read through each question and trying to solve it, or at the very least, visualize how you would solve it. You might not be able to execute all the steps in your head if you're on the go, but just do your best. If you're in a situation where you can physically write down what you would on test day, that is ideal and highly recommended. We're going to start with a lower difficulty level warm-up problem, and then we're going to bump up the difficulty level from there. This is our warm-up problem. The problem says if M, the letter M as in midnight or Monday, if M is the average, in parentheses, arithmetic mean, of the first 10 positive multiples of 5, and if capital M, as in Monday or midnight, is the median of the first 10 positive multiples of 5, what is the value of capital M minus lowercase m? I'll read that again. If lowercase m is the average of the first 10 positive multiples of 5, and if capital M is the median of the first 10 positive multiples of 5, what is the value of capital M minus lowercase m? Option A is -5. Option B is 0. Option C is 5. Option D is 25. And option E is 27.5. I'd recommend pausing here and getting as far as you can on your own. This is an excellent warm-up problem and a great way to introduce some key concepts from statistics, which is what we're going to focus on today. You've probably learned in the past what averages and medians are, but it may have been a while. So let's start with some definitions. The average, which the test will sometimes refer to as the arithmetic mean. In fact, they'll usually do that. And they'll typically do it exactly the way it shows up in this problem. I read it the first time, but not the second time. So it says average in parentheses, arithmetic mean, and then they close the parentheses. You really don't need to concern yourself with that. It's the way that you've thought about averages your entire life, probably. And if you're unsure about that, you can feel free to web search it. But as far as getting a high GMAT score goes, just think of the average as the sum of the values divided by the number of values. Again, average is the sum of the values divided by the number of values. Sometimes the test is going to refer to that as the arithmetic mean. If you know that, then you can brute force this question, quote unquote, brute force the question by just computing that. And that isn't necessary to answer the question, but it is doable. And we're going to circle back on that concept of like when we would brute force versus when we wouldn't. We'll circle back on that in a minute. So that's the average. You'll also want to remember that the median of a set of numbers is the middle number of an ordered list. Again, the median is the middle number of an ordered list. If you've been studying for a while, you're probably rock solid with this stuff. If you're just getting started with your studies, might have been a while since you thought about what a median is, and that's fine. That's where virtually all of us begin. That's where I began. And yeah, had to relearn what the median was the hard way. So the key there is that the list must be in order from least to greatest or from greatest to least. That's super, super important. A lot of people mix that up. One quick note is that if there is an even number of numbers in the set, like the set 2, 4, 6, 8, let's say, which has 4 terms in it, then the median is the average of the 2 middle numbers. So if there's an odd number of numbers, the median is going to be that middle number in the set. If there's an even number of numbers, then you're going to average the 2 middle numbers, and that's going to be the median. So a little bit to memorize here. If this isn't already rock solid for you, I'll just repeat a little bit of that in case it's helpful. If there's an even number of numbers in the set, like in the set 2, 4, 6, 8, then the median is the average of the 2 middle numbers. Technically, that's still the middle number of an ordered list, but that can throw people off a little bit. So it's usually important to memorize both parts of that definition for optimal results. So if there's an odd number of numbers, the median is going to be that middle number. It's going to be one of the terms in the list. If there's an even number of numbers, it's usually not going to be one of the terms in the actual list itself. It's going to be the average of the 2 middle terms. So in the case of 2, 4, 6, 8, the 2 middle terms are 4 and 6. We average those. Median of that set would be 5. I guess just while we're on the subject of averages, that's 4 plus 6, the sum of the numbers divided by 2, the number of numbers. 4 plus 6 over 2 is 5. So as promised, let's circle back on this brute force approach I mentioned. We'll walk through that, and then we'll discuss some of the higher level stuff that might be worth learning here. So brute forcing the first piece, which is the average of the first 10 positive multiples of 5. We can just list those out. 5 times 1, 5 times 2, 5 times 3, 5 times 4, all the way up to 5 times 10. And I would compute all those numbers, and I would just add them up. 5 plus 10 plus 15 plus 20, etc. All the way up to 50. If you do that math properly, that should get you 275. 275. So a lot of math there, but there's a time and a place for this. If we then use the average formula, which again is sum of the numbers divided by the number of numbers, we would have 275 on the top. That's the sum. And then, of course, we would divide that by 10 numbers, because it's the first 10 multiples of 5, to get 27.5. So that's our average. Let's work on solving for the median. Good news is we already listed out all the numbers in order. 5 times 1, 5 times 2, 5 times 3, 5 times 4. That's already an ordered list. And because there's 10 numbers in the list, we know that the median is going to be the average of the 2 middle numbers. There's a few ways to do this. What I recommend, and this might seem really painstaking, but I really think you're going to find this valuable as you progress through your studies, is you can just visually cross off 4 numbers on both sides of the list. So imagine you have those 10 numbers written out, cross off the first 4, cross off the last 4. That leaves you with the 2 middle ones. I know that might sound really elementary, and I'm sure there's a lot of you who are just incredibly intelligent, incredibly great test takers out there who are like, what are you talking about? I can do that in my head with ease. But that's great. That's great. If you're one of those people, that's amazing. Most of us are not that person. And so it's just really easy to lose track of which number is which in the list and then average the 2 wrong numbers. That's just so painful. So painful when that happens, because it's a multiple choice test. There's no partial credit like many of the math tests we're used to taking in school. And so you could have everything right except that one piece, and then the whole problem is wrong. And yeah, you'll hear me talk about this kind of stuff a lot, this sort of like preventative insurance type habit building. And I really think it's going to get you a higher score. I've seen it happen tens of thousands of times, hundreds of thousands of times at this point. And it works. Let's just put it that way. So I recommend visually crossing them off. But of course, you can just count into the list and find the 2 middle values. That also works, but it's a little more dangerous. And no matter how you figure that out, you will hopefully realize the two middle values are 25 and 30, the fifth and sixth multiples of 5, respectively. So let's average those. 25 plus 30 is 55. We divide that by 2, and we get 27.5. Now, the question is asking for capital M minus lowercase m. Capital M is the average. Lowercase m is the median. And as you probably already know, at this point, that's going to give us 27.5 minus 27.5, which of course gets us 0, which leads us to the correct answer, which is option B, as in beta. So obviously that works. And again, there's a time and a place for that kind of thing. Let's just briefly step back on that. Usually the time to brute force is 1 if you can't think of any other way to do the problem. Okay, well then if brute force is the only way you can think of doing it, it's probably a good bet, as long as it's not going to take you more than, let's say, 3 minutes. Or if you have extended time on the exam, if you have 50% extended time, if it's not going to take you more than like 4.5 minutes. If you have 100% extended time, it's not going to take you more than 6 minutes. That would be like the upper limit of what I'd invest in any given GMAT question, which you might note is over the average question of approximately 2 minutes per question. That's a longer conversation with a lot of advice attached to it. And I've gone super in depth with that in a bunch of past episodes, such as how to build speed, which we'll link in the description for you. Let me just make that note real quick. And also how to structure your GMAT study time, I think is the name of the episode. We'll link that for you, but it's basically talking about how to make good decisions during your study sessions. And I think you'll find both of those quite valuable. But I think a lot of people are surprised when I recommend giving themselves more than 2 minutes per question on certain questions. Obviously, you can't afford to spend that on every question and still have a shot at every problem on the test. But every once in a while, if you feel like things are going well, then it might be okay to borrow from a future question to get the current question right. And that's usually a good trade when you have a high conviction that your strategy is going to work and there's no alternate strategy on the table. Hence my advice of when to use the brute force approach. But if there is a faster way that's not too risky, then that's definitely the ideal. And if you've been following for a while, you've heard me talk about that risk-reward trade-off a lot. In this particular question, there's a good shortcut that's very worth knowing, that has very low risk and has a ton of upside. But it's really valuable to understand the brute force approach, especially if you're just getting started with statistics. So I did want to talk through that, mostly for teaching purposes, but also for strategic purposes. So while I do believe it is an excellent idea to know how to do that solution we just walked through and to be able to execute it well, it's also a good opportunity to introduce you to this shortcut. Now, this shortcut only works for sets that are evenly spaced, meaning that there's the same distance between every term in the list. Couple examples of evenly spaced sets: 1, 2, 3, 4, 5. That's evenly spaced. Every term differs by 1. Or 10, 20, 30, 40. Every term differs by 10. Or 3, 18, 13, 3, 8, 13, 18. Those all differ by 5. Consecutive multiples of 5 like we have here, or consecutive multiples of 7, those are always going to be evenly spaced sets. So in this situation, because it's consecutive multiples of 5, it's evenly spaced. So in those kinds of lists only, you will always know for sure without needing to do any math that the average is going to be equal to the median. It's a property of numbers that's potentially worth exploring if you're not super interested in the theory behind it and you're just trying to get this test done and go to business school. I probably wouldn't worry about it too much. I'd just memorize it. But if you're interested in that kind of thing and you find it compelling and you find that that helps you memorize it and leverage it to understand some of the conceptual pieces behind it, then by all means, a quick web search will get you some good examples and some good explanations as to why the mean is equal to the median in evenly spaced sets. But I just want to emphasize it is not true of all lists. But because it is true of evenly spaced sets and evenly spaced lists, same thing, and those do come up a lot on the GMAT, it's definitely worth memorizing. Because if you know that the average and the median are going to be the same, that saves a just comical amount of time. Like the problem's like 10, 20 times faster with that. It'd probably transform maybe like a 2-minute question or a 90-second question into like a 20-second question. I mean, hard to estimate. If you have high conviction in the process, then it's going to be a pretty quick win. So it's really nice. It's really, really nice when we can do that. I've talked a lot about pitfalls in questions in past episodes of this series, and I think those are really important discussions to have for a ton of reasons that we've already talked through. And so I've warned you off of a lot of shortcuts that I think are really risky for most of us, even those of us aiming for super, super high scores. But this one, not so much downside, tons of upside. So really, really great tip to have in your back pocket. Again, concept of average equals median and evenly spaced lists comes up in a variety of other question types. And so you're probably going to get a lot of mileage out of it. That's probably more than enough for our warm-up question there. I'd recommend pausing and just making any notes to self about what you might want to recall from that discussion, and then we'll try a question that's a little bit more challenging. Next question. Question says, 5 pieces of wood have an average, in parentheses, arithmetic mean, length of 124 centimeters and a median length of 140 centimeters. What is the maximum possible length in centimeters of the shortest piece of wood? I'll read that again. 5 pieces of wood have an average length of 124 centimeters and a median length of 140 centimeters. What is the maximum possible length in centimeters of the shortest piece of wood? Option A is 90. Option B is 100. Option C, 110. Option D, 130. Option E is 140. Again, recommend pausing here and getting as far as you can on your own. Okay, slightly more complex statistics question here, but obviously integrates some valuable concepts from the first problem. Like most word problems, visual organization is probably going to be really key to getting this right. So I typically, as usual, recommend writing what's given and asked really clearly as a first step. We're told there are 5 pieces of wood. The average of those is 5. The average of those 5 is 124 centimeters in length. So I would just write both those things. 5 pieces, average equals 124 centimeters. We're also told the median length is 140 centimeters, so I would write that as well. We're asked for the maximum possible length of the shortest piece. I would write that also. And it's always worth writing the question really clearly. But in this particular situation, I can definitely see myself getting mixed up and solving for the maximum possible length of the longest piece, especially if I'm not being careful or if I'm stressed, time pressure, distracted, a lot of things that can happen on an official GMAT. In fact, we looked at some pitfalls of not writing that kind of thing in last week's episode. So I'm not going to hammer that point too hard today, but it's worth a listen to episode 41 if you want some advice on how to prevent that kind of thing. All right, so we got everything listed out. Where do we go now? So let's visualize what we know about the list. And let's draw something like 5 dashes. I'm going to then write the median in the middle, and then I'm just going to take a step back for a moment. If we want to maximize the smallest value of the list, that basically means we want all the other items in the list to be as small as possible. And that's because the sum is given to us. We can't change the sum of all the lengths. So our best bet is to try to allocate as much of that fixed sum to the smallest length as we can. So just to walk through that. So they tell us that the average of the 5 pieces is 124. So if you visualize the average formula as um, sum over 5 equals 124, then I can just solve for the sum there by multiplying both sides of the equation by 5. That'll give me the sum. So when you're told the average like that, and you're told the number of items, you'll usually be able to calculate the sum. And once you have that sum, or once you at least know you could calculate that sum, that lets you know the sum is fixed. So we can't just expand the sum infinitely. We have a limited number of total centimeters that we can allocate to each piece of wood. So that's why I'm saying if I want to maximize the smallest piece, that's another way of saying I want to make all the other pieces as small as I possibly can. That allocates the maximum amount of the sum to the lowest value. So conceptually, that's going to underpin our strategy choices going forward. And you'll definitely see questions like this with some regularity. So if this is new for you, or you're like, I don't know if I would have thought about that, which is definitely what I thought the first time I saw a question like this, that's fine. That's why we're here right now, is to help you grow and help you improve and expose you to things that will be helpful. If you've been studying for a while, you might already be super familiar with this concept, but just for all of you who are getting going, there'll be great opportunities to make notes to self on this one if you weren't aware of that concept. And it's a good thing to have in the top of your mind anytime you're doing statistics questions. It's a common thing. So a good way to take away as much length from the other pieces as possible in order to allocate the maximum length to the smallest piece is a little counterintuitive, I think. And it's to make the two pieces that are quote unquote larger than the median. Like if you imagine those 5 dashes with the median written in the middle, the two to the right, we're going to make those exactly equal to the median. When I was first starting out, I thought that was like really counterintuitive. It ran very much against my instincts. I'd often write things like 141 and 142 just like without even thinking about it for the longer pieces. And I wasn't even, yeah, I mean, I think the thing there is like there are questions that say 5 distinct lengths. And in that case, I can't use 140 multiple times. But if they don't say distinct lengths, then I want to default to thinking, okay, maybe I can make some of the lengths equal to each other. Again, it's just not something most of us have thought of until we've seen GMAT questions like this. And that's the whole reason it's valuable to go through real GMAT questions. So I think it is worth harping on that point, since you'll probably see it again. And again, unless the question literally says different or distinct or something like that, just assume the lengths can be equal, and that'll put you in a position of strength on these problems. If we do that here, then that's as small as those can be. Because if either of those are any smaller, then the median won't be 140 anymore. And again, that's a concept that might be worth playing around with if you find that understanding and messing around with that stuff helps you memorize it. But it's also okay not to worry about that. If you're like, that kind of makes sense to me. Like 140 is the median. I make the other two equal. That minimizes those and therefore maximizes the stuff I want to maximize. Like, that's fine. You don't need to go any further than that. But if you want to play around with making one of the numbers 130 or 139 and see how that would change the median, if that's helpful for you, then I definitely encourage you to experiment with that. Okay, so what we've done there is we've freed up a lot of the overall sum to allocate to the smallest piece. I've said that a bunch of times, but I think you'll thank me later for hammering some of these points, because I think it'll help it stand out in your mind when you're under time pressure. So I'd have those written, and I would have the 5 spots with 140 in the middle, and to the right 140, and to the right of that another 140. And now we can go about maximizing the other 2 spots. There are actually a few options for doing that. I'm going to start with just guessing and testing, because it's not that bad of a move in a situation like this. And I think that'll also be a nice lead into some of the shortcut methods you can use. So yeah, there is an algebraic method. If you're having success with that, don't necessarily change it. If things are working well, keep doing it. I'm never going to argue with your results, but let's just talk through the guessing and testing thing as a good way to learn some valuable background concepts. And also it is a totally acceptable strategy for solving the question. So I'm going to look at the answer options. We're being asked for the maximum, so we might as well start with E, which is the largest available value, which you might remember is 140. So if we plug in 140 for the lowest value, that gives us only one value to solve for. So we'd have 140, blank unknown value, and then 140, 140, 140 for the median and the 2 quote unquote largest values. Now we already know the average, and we could use that to solve for the sum. Like we said, the sum's a fixed number here, but we still don't know what that exact value is. So let's just go ahead and find that. So sum divided by number equal to average. So here we would have sum over 5 equals 124, like I said earlier. Don't be afraid of long multiplication. If you have not done long multiplication in a while, we've got a Math Basics series that will help you upskill quickly with a lot of those foundational things that are tested on the quant section, and there's no calculator on the quant section. So things like long multiplication, long division are really valuable. And I've done so much long multiplication on the pod, everybody. I'm going to gloss over that. But it's in that Math Basics series if you want. So if we do that math correctly, we would get 620. So again, if we add up all the 5 values we have, we should get 620. Knowing that can help us. Now, if we assume the smallest value is 140, again, guessing and testing with option E, that would mean that all 5 values have to be 140. Because if the smallest is 140 and the median is 140, then that second value has to be 140. There's like nowhere else for it to go. And in that case, we actually don't need to do the math, because you could step back and realize that 140 times 5 is going to be much bigger than 124 times 5. You don't have to go there. It's fine to just add 140 5 times and realize it's too big. But it is kind of a nice move there to step back and be like, okay, well, that's definitely not going to work. So we will definitely not be able to make the smallest value 140 and still meet the constraints of the problem. So let's cross out E and let's try D, which is 130. If we write that in as the smallest value, and we keep the median as 140, which we have to, and the other two quote unquote larger values as 140, then the smallest that the second value could be would be 130. And we want that second value to be as small as possible to maximize the first value. But you might already be able to tell that 140 plus 140 plus 140 plus 130 plus 130 is going to be a lot bigger than 124 plus 124 plus 124 plus 124 plus 124. But if that's not making 100% sense, just go ahead and add all the values up. 140 3 times would be 420. 130 2 times would be 260. 420 plus 260, we get 680. So again, too big, which because our exact sum should be 620. So we'll go a little bit smaller with option C. Option C is 110. If we make the smallest value 110, the smallest that the second value can be is 110 as well. We already did the math on 140 plus 140 plus 140, which is 420. If we do 110 plus 110, we get 220. 220 plus 420 gets us 640. So again, still too large. Let's go for B, which is 100. 100 plus 100 is 200. Plus 420, that's 620, which is exactly the sum we want. So B can definitely work. Now, why should we not even try A at that point? Remember, the question is asking for the maximum value of the smallest length. So if 100 works, trying 90 is not a good idea, because even if that works, it's a smaller overall value, which we don't want. So that means we should select B as in beta, which is our correct answer. A lot of us go for A, though. About 10% of us. And I think that's probably as simple as forgetting what the question is asking. That would be my guess. Like, people, instead of trying to maximize the smallest value, they try to minimize the smallest value. I've definitely done that many times myself, those kinds of mistakes. So you're not alone if you made that mistake, but perhaps obviously you'll want to correct it. And that's usually a simple fix. Just notate what's asked more clearly. I was talking about that at the top of the problem. Those kinds of habits can come from a lot of experience. And I like just boxing, like putting a box around what the question asks, or writing it way bigger than everything else. Both of those things are something similar, tends to work well. So figure out what works for you and stick with that. Having said all that, I haven't seen that be the main bottleneck for folks on questions like this one. It's definitely a big issue, and that's why we've gone in depth on it on like so many past episodes. But I think the main bottleneck on these types of questions is that people don't realize the median can be equal to other values in the list. I've just seen it so many times. And like I told you, done it many times as well. People go like 140, 145, 150, or 140, 141, 142. And I think that might also be a reason a lot of people are going for A, because if you make those quote unquote high S2 values bigger than 140, then you're not going to be able to make 100 work as the smallest one and still get a sum of 620. So I think a lot of people end up defaulting to 90 there. So I think there could be a couple potential takeaways on this one, depending on where you see yourself making mistakes, if you made mistakes at all on that one. One more time, I think the big one's probably making a note to self that the median can be the same as other values in the list, and to look out for those words different or distinct. And if they're not there, assume that you're probably going to want to make some terms equal. But it's up to you. Either way, as usual, I recommend pausing here before we move on to our final question and just making any notes to self that you'd like to recall for future problems. Last problem today. A certain list consists of 21 different numbers. If n, as in never or nobody, is in the list, and n is 4 times the average, in parentheses, arithmetic mean, of the other 20 numbers in the list, then n is what fraction of the sum of the 21 numbers in the list? Sorry, it's a bit of a mouthful there. Let me read that again. A certain list consists of 21 different numbers. If n is in the list, and n is 4 times the average of the other 20 numbers in the list, then n is what fraction of the sum of all 21 numbers in the list? Option A is 1 over 20. Option B is 1 over 6. Option C is 1 over 5. Option D is 4 over 21. And option E is 5 over 21. Again, recommend pausing here, get as far as you can. I'm just going to jump into my commentary. Good challenge question here. It's almost certainly not the most difficult question that you're going to see during your prep, but it's definitely not easy for most of us. Quite a few of us miss this. More on that in a little bit. I think part of that high rate of missing it is that it asks us to set up some quantities and do some algebra in a somewhat unnatural way. So I'm going to focus a little bit on that. For some of you, that was probably no big deal, especially if you're strong with word translations or strong with algebra. But for a lot of you, it was probably pretty tough. So I'm going to do my best to talk you through some ways that you can get around that. Some hard-earned tips that I came across when I was in your shoes and that I've found to be super helpful for lots and lots and lots of folks I've helped through this process. And might be a little difficult to talk through, but I think you're going to find it more than worth it. So let's just get into a good algebraic solution that integrates some of the other themes that we've already talked about today. First things first, we'll definitely want to be super clear on what's given and asked. And this question is a really good example of how the test writers are sometimes going to give you clues as to how to solve based on how they present the given information and based on how they ask the question. So while it might seem redundant to write what's given and asked on every problem, I really do think you're going to find it's going to pay off. We're first told there's 21 different numbers, so that's quite relevant to what we were talking about on the previous question. Different, we want that to be like loud and clear in our minds, and definitely be not thinking about like making any numbers in the list equal, like we were able to do on the previous one. So I'm going to note that if I'm doing this on my scrap paper, I'm going to write that really big. Again, I can see myself messing that up. And we're told that n is one of the numbers in that list, so let's note that. And we're also told that n is 4 times the average of the other 20 numbers. So I'd write that as well. It's a good time to use some half math, half English. I've gone in depth on that on past episodes, and we try to title all these episodes with the main topic that we're covering in them. So if you search word problems or word translations, you'll find all the real GMAT question episodes that I discussed that particular thing in. And hopefully that makes it a little bit easier to drill down on the stuff that you want more practice with over time. Okay, so the half math, half English thing is I'd probably just write if you're on the pure audio feed, n and then an equal sign and then 4 and then a multiplication sign. And then in parentheses, I would literally write the words average of other 20. And so that's not like 100% math. It's not 100% English, but I've found that to be a good interim step on word problems so that I'm not forcing myself to try to get to the equation too quickly. I know that might seem just like way too heavy-handed of a recommendation, but if you're just crushing all word translations and you're not having any issues with them, then great. Don't stop doing what you're doing and just keep doing what you're doing. But if you're like most people, that is a major weakness coming into your prep on the quant section. And so that half math, half English thing can be really good. So you don't overload your short-term memory at the beginning of the problem and it starts to short circuit a little bit. Because we can usually only hold about 7 things in our short-term memory. And that's taxed really heavily on these questions where there's more than 7 things to keep track of. So that's partly why just the half math, half English, like intermediate step before you turn it into an equation can help you get the big picture of the problem. And then that can help you make better strategic decisions, which I'm going to talk about is really helpful in this type of problem. So we then get the question. I'd probably express that as a fraction when I'm writing it down. And again, I'd use some half math, half English there. I'd probably write something like n with a fraction bar underneath it, and then sum of all, like written in actual English in the denominator of that fraction. So again, that just keeps me from getting bottlenecked too early in the question and like getting sucked into the details when I haven't even figured out my big picture approach. At this point, we'd have the basic lay of the land. And this is where we can use some of those clues I was talking about. So they've told us that n is equal to 4 times the average of the other 20 numbers, which if you think about it is kind of an unusual thing to present. And it's definitely an unusual relationship. Like most of the time we would have a relationship to the overall average, not just the average of like a segment of 20 out of the 21 numbers. And usually when you're presented with something like that, it's a clue about how to set up the question and how to execute on the question. And coming into the GMAT, that was just so foreign to me. Like I just thought they were trying to mess with me when actually, if I had just seen that better, I could have realized they were actually like helping me out. So I'm going to focus on that for all of you here and try to help you progress with this faster than I was able to. It's a clue to make a variable for the sum of the other 20 numbers. And that goes back to the average formula that we started the lesson with. So remember, average equals sum divided by number of items. We know that the number of items is 20, 21 numbers minus n, because we're not including n. But we can't compute the average without the sum. And note that we are also asked about the sum in the question. That's another clue there. So when they're asking you about the sum or telling you about a relationship of a sum or an average of a small segment of the list, that's a clue, because that's a little unusual. So what we can do to capitalize on that is create a variable for the sum of the 20 numbers that are not n. So I'm going to use something distinctive. I'll use the letter Z. I like to avoid the letter S, even though I have talked about using representative variables in past episodes, like S for sum would make sense, but S's, at least in my handwriting, they often look like 5s. So I try to avoid those. So I'll use Z instead. And I really just want to hammer this point. It would be really unusual to make a variable that represents part of the numbers in an average computation. But here, we're given those clues in the prompt. They literally give us a relationship with that value in it. And so that's your cue to be like, okay, that's kind of weird. Maybe I'll just make a variable for that specific weird thing. And the more you see that work out, I think the more you'll be able to trust it. So we're going to use Z in order to set up some equations based on the given information. So the first thing that having Z allows us to do is use the n is 4 times the average of the other 20 numbers. And we can make that into a pretty clean equation. So I would just write n and then an equal sign and then 4 and then times in parentheses Z divided by 20. Z is the sum of the other 20 numbers. Divide that by 20. That gives us the average of the other 20 numbers that are not n. So n equals 4 times Z over 20. That's a nice distillation of what I wrote for my half math, half English. And now this is pure math, so I'll be able to operate on it. I can also use Z to distill the question a bit more, because the question is asking n is what fraction of the sum of all 21 numbers in the list. So I'd probably rewrite that in pure math form as n, and then a fraction bar under it, and then z plus n in the bottom. And then I would write equals question mark. That's what I'm trying to solve for. So if z represents the sum of the other 20 numbers, then z plus n represents the sum of all 21 numbers. And I think for a lot of us, that would just be like too clever, too insightful of a move to get to, unless you're thinking, that's kind of a weird thing for them to ask about or like tell me about the sum of these other 20 numbers. Let me make a variable specifically for that. Oh, look, I can use that in the question as well. Like, I think that chain of logic is just, maybe that's not easy for you, especially if you're starting out, but it's more believable. I think it's easier than the question without that tip. So if I can get there, if I can get to that piece, then I can start to see a path to the correct solution because I can solve for z in the first equation and then do some substitution. And I'll walk you through the details of that in a second. But I just want to pause and say that, again, if you're just starting out or algebra is not a strong suit for you yet, this is probably going to feel a little hard to reach, and that's okay. Part of the reason we're here right now is to improve, and that means stretching your skills, maybe stretching them a lot. But the point is, if you keep stretching those skills, they'll grow. And that's really the point of your preparation, is not to stay the same. It's to improve. So try not to worry if you start to feel like questions like this are a little beyond your skill level right now, or maybe even a lot beyond. You'll for sure get better, unless you give up. So as long as you don't give up, you're doing the right thing, and you'll keep improving over time. The reason I bring that up now is most people find it hard to do a couple of the things we've done so far. Again, I'm just going to rehash this. Number one, it's hard to recognize that you should create a variable for the sum of the 20 other numbers. It's just a little weird. You probably haven't done that very much in your mathematical career, unless you did a lot of heavy math in high school and college, or you do a lot of heavy math in your job. But now you know that you can use clues in the problem to help you do that. So that should make life a little bit easier going forward. Number two, it's a little hard for a lot of folks to recognize how to use that variable, even when they have it. I was talking about this, translating the question into n over z plus n can feel like a little bit of a reach. Like, how would I know how to do that? And again, the key is just noticing when the question tells you something unusual and or asks you for something unusual. If you notice that and you ask yourself, how can I use that to my advantage? Now you'll hopefully have stored in your memory that creating a variable for that specific weird thing is probably the right approach to the question. It's not a 100% thing, but it's like a 95% thing. Okay, so let's get back to solving now that we've made those points. So we've got n equals 4 times z over 20, and we've got n over z plus n equals question mark. So let's solve for z in the first equation and then substitute. So if I have n equals 4 times, in parentheses, z over 20, I'll probably just divide both sides by 4. In case you're on the pure audio feed, I'd probably start canceling if I was doing this on my own. But just if you're on the pure audio feed, that might just be a little weird to think through. So I'm just going to divide both sides by 4. We've got a math basics episode on algebra. Side note, if it's been a while since you've done some algebra. So that'll be linked in the description for you as well. If I divide both sides by 4, I got n divided by 4 equals z divided by 20. And then I'd multiply both sides by 20 to isolate z. That's going to give me 20 over 1 times n over 4 equals z. If you've been a follower for a while, you know I like to write fractions that way to make it easier to cross cancel. We can now cancel 20 and 4 to get 5 times n equals z. We've also got a math basics episode on fractions below if it's been a while since you thought about cross canceling stuff. And 5n equals z is definitely clean enough for a substitution. So let's go ahead and plug into our question, which you might remember is n divided by z plus n. We just figured out that z is the same value as 5 times n. So I'm going to plug 5 times n in for z. And I can sort of see a couple steps ahead in the problem and see that the n's are going to cancel out there. And that's nice because I'm going to get something that looks a little bit more like the answer options, which don't have any variables in them at all. So that helps me know I'm on the right path. If I made that substitution, I would have n divided by 5n plus n. Let's consolidate the denominator to make that 6n. And then our question is n divided by 6 times n equals question mark. We can cancel out the n on the top and bottom, and we get 1 over 6, which is our correct answer, which is option B, as in beta. So what can we learn from something like that? I think I already hammered the points home, but I'll just hit it one more time in case it's helpful. If a question gives you something strange, like a strange or unusual quantity, or it asks for something strange, use that information. It's probably the key to answering the question efficiently, and consider setting up specific variables to represent those weird things. If that was a really big struggle to put together here, I recommend returning to this problem a few times over the coming days. Just re-listen to the episode. You can send yourself a time-stamped link on most platforms. Resolving questions that were hard for you the first time is one of the best ways to improve your skills, and I've found a lot of people resist it. And I think it's because it just doesn't make us feel like we're moving forward. It makes us feel like we're moving backward. Like, how could that possibly help me? But if you try it out, I think you'll realize it's one of the wisest things that you can integrate into your prep going forward. And again, if you go to that how to spend your study time, how to structure your study time episode I referenced earlier today, I'll talk about that a little bit more in depth if you want to put a little bit more structure around that resolving technique. Really, really valuable. Okay, I think that's more than enough on statistics questions for today. As usual, I recommend pausing right now and make any desired notes to self that you would like to remember on future problems. If you have any questions about anything we've presented here, or if you have feedback for us, please touch base anytime. We're at the GMAT Strategy on current social channels, or you can email us if you like. Our email address is contact, CONTACT, at thegmatstrategy.com. As always, my greatest hope is that this material will make your studies as easy and as painless as they can possibly be. If you want more tips and strategies for optimizing your performance on the exam, please head to our website, thegmatstrategy.com, which is linked in the description of this content, and check out our free video on how you can reach your dream GMAT score in half the normal time. In the meantime, this is a regular show, so please subscribe and please stay positive and stay consistent with your studies, everybody. Talk to you soon.